Assalamu alaikum. Welcome to the third part in our lesson Limits and Continuity. Our objectives are recognize and calculate right and left limits of a given function at a given point. 2. Recognize piecewise functions. Please prepare your materials to start. First, let's recall together how to find the limit. We used substitution. If we find the answer, we stop. If not, and we get one of the indeterminate forms, we use factorization then simplification, or multiply by the conjugate and simplify. Let's start with activity 1. Given f a function defined on minus infinity 1 union 1 infinity as f of x equal x squared minus 1 over x minus 1. Needed to complete the table below. For each value of x, find the value of f of x. We observe that all the values can be calculated in the table except 1. This is why 1 is not in our domain. So, in this case, we find the limit of f of x as x approaches 1 from left, or very closer to 1, or x approaches 1 from right, or very closer to 1 and greater strictly than 1 if they exist. In the given number line, we see the limit as x approaches 1 from left and as x approaches 1 from right. We say x tends to 1 minus, example, x approximately 0.99999, or x approaches 1 from the left. We say x tends to 1 plus, for example, that is 1.00001, and this is how it approaches 1 from right. As a result of our activity, in the preceding activity, since f of 1 does not exist, we find the limit of f of x as x approaches 1 from left and as x approaches 1 from right. We say limit of f of x as x tends to 1 plus, that means from 1 closer to 1 from right. We substitute x by 1 in the equation of f of x and find the limit. Similarly, we do the same for x tends to 1 minus, or the left limit of x at 1. We substitute x by 1 in the equation and we get our answer. Here we simplify x minus 1, which is the condition of our domain. That should not be 0 first, and then we can calculate our limits. We see that the left and right limits at 1 are equal to 2. Then we deduce that the limit of f of x as x tends to 1 is equal to 2 because of the following property. In general, we say that the limit of a function at a point A exists if right and left limits of f of x at the same A are equal. So we write limit of f of x, x tends to A, x less than A, that's A minus, is equal to limit of f of x, x tends to A, x greater than A, that's A plus. Here, right and left limits are equal at A, so this is the limit of f of x at A. As a geometrical interpretation, the adjacent graph represents the representative curve of fx equals x2 minus 1 over x minus 1. We see that as x approaches 1 from left, see x-axis at 1 minus f of x approaches 2 in the graph. As x approaches 1 from right, fx approaches 2 also in the graph. Now let's consider the following properties. We say x tends to 0 minus means x tends to 0 and x less than 0. So 0 minus is less than 0. As an example, minus 0.000001. Another example, 2 minus is less than 2. So 2 minus minus 2 will be negative. 2 minus minus 2 will tends to 0 minus. If x tends to 2 minus, then x minus 2 tends to 0 minus, because 2 minus minus 2 tends to 0 minus. Let k be a real number, k not 0. We deduce that if k is positive, k over 0 minus tends to minus infinity, k over 0 minus tends to plus infinity if k is negative. Now, for 0 plus, it's greater than 0. X tends to 0 and greater than 0. As an example, plus 0.000001. So, 2 plus is greater than 2. And 2 plus minus 2 will be greater than 0. If x tends to 2 plus, now x minus 2 tends to 0 plus. We deduce that let k be a real number with k not 0. If k is positive, k over 0 plus tends to plus infinity, and if k is negative, k over 0 plus tends to minus infinity. Examples about right and left limits. Needed now to find the limit as x tends to 2 for minus 3x over x minus 2. Here x should be different than 2 in our denominator. So here we should find right and left limits first. First, the limit as x tends to 2 minus, we substitute x by 2 minus and we get minus 6 over 0 minus that tends to plus infinity. But the limit as x tends to 2 plus will be minus infinity. Here, left limit and right limits at 2 are not equal. So the limit of this function as x tends to 2 does not exist. Another example. Limit of x plus 3 over x as x tends to 0. Since 0 is in our denominator, we should find both right and left limit as 0. First, our left limit at 0 is minus infinity, and the right limit at 0 or 0 plus infinity. Also, different right and left limits, so the limit does not exist. Another example. Limit of 3x at 1 plus x squared at 1 minus. Here, 1 minus we substitute it by x and the limit exists. Now, the limit at 3x plus 1, x plus 1 at minus 1 minus. Need to find only the left limit. We substitute and we use the table of sign to see the sign of x plus 1. As x tends to minus 1 minus, we stick our view before minus 1 in the table of sign to see that it's minus, so the limit is plus infinity. Now, let's find the limit the right limit at 2 plus of this function, we also use the table of sign to find the sign of 10 minus 5x. To see that using the table, as x tends to 2 plus, we have a negative sign, so our limit is minus infinity. Now, the limit at x tends to 0 minus will be plus infinity. This application is for you. Please go back and revise the rules and then start alone. Now a new objective. Let's define together piecewise functions. A piecewise function is defined by at least two expressions, each of which applies to a different part of the function domain. Example, now given f of x, as we see as two expressions. The first one is minus x for x negative. This is the first part of the domain. And the second one is fx will be equal to x if x greater than or equal to 0. Does f have a limit at 0? Justify your answer. We will use the following table. We see that as x negative, the following values as x tends to 0 and x greater than 0. If we graph this function, we observe that the limit of f of x as x tends to 0 plus is 0, and the limit of f of x as x tends to 0 minus is 0. So the limit of f of x here as x tends to 0 is 0, having equal right and left limits at 0, so the limit of f of x as x tends to 0 exists. Please do application 2 alone. Please. This is a summary for you about limits. Try to copy it alone, revise it well, and this is your assignment. Please do it and send it for me. If you miss some details, watch again the video, please. This is our video today. Assalamu alaikum.